Okay, using trigonometric ratios to find angles. So just reminding you what your trig ratios are, your sine, your cos and tan. Using SOHCAHTOA to remember the order of opposite over hypotenuse for sine, adjacent over hypotenuse for cos, and opposite over adjacent for tan. So you should know those off by heart by now. So if you've got a question, which of the ratios do you use? Well, in every question that you get, two sides of the right-angled triangle will be mentioned, whether one of them has a variable or a pronumeral on it and the other one has a number, or they're both numbers. If they're mentioned, two of them, then you can work out which of the ratios you are using in relation to one of the angles. So, well, how do we do these ones? Let's have a look. In the first one, we have the opposite side and the hypotenuse side. So that should tell us it's our sine. In the second one, we don't have the hypotenuse, but we have the opposite and the adjacent, so that tells us it's our tan. In this last one here, we have the adjacent and the hypotenuse, which tells us that it's our cos. So trigonometric ratios, to using them to find angles. So can you put your heading down? Trigonometry, finding angles. Example 1, so to find theta to the nearest degree. So here's your question. So what steps do we take? To find a missing angle from a right-angled triangle, we need to know which of the two sides of the triangle we're given, so we can work out our ratio. So steps. Number 1, we need to label the names of the sides. So what have we got here? We have got the hypotenuse side, and we also have the side next to the angle, which is our adjacent side. So once we've worked out those, we can go to step 2 and determine what ratio has those sides. So the adjacent and hypotenuse goes with cos. Our third step is then to solve our ratio by putting in any information we can. So we know the adjacent side is 6, so where we see the A, we're going to be putting a 6, and our hypotenuse is 14, so where we see our H in our ratio, we put the 14. Then to solve that on the calculator, again making sure you've got it in degrees, you have to press shift and cos because we're finding the angle. So you shift cos to find the angle, and then you can put it in fraction form, 6 over 14, okay, across and close your brackets, equals. Now this you can put into degrees and minutes by pressing that. Now this question's asking to the nearest degree, so we only need to write down the first section, but we need to round off carefully. Because these minutes are over 30, we have to round that up to 65 degrees. So then you just write your answer in, theta equals 65 degrees. Can you write this first example down? You'll need to pause the screencast. Okay, example number 2. This one, the question is asking to the nearest minute. I've already said this is our opposite side, and this here is our adjacent side because it is next to the angle. This one's next to the angle as well, but because it is the longest and opposite the right angle, that's special hypotenuse. So the opposite and adjacent, the ratio related to that is tan. We solve the ratio by substituting in our information. Our opposite side being 7.5 goes there. Our adjacent side of 3 goes there. And then we solve that on our calculator. So on our calculator, we press shift, tan. We put in our fraction, 7.5 over 3, arrow across, close your brackets, equals shift. Oh no, sorry, don't have to press that. So get rid of the shift. Degrees, minutes. Now to the nearest minute, we've got 68 degrees, and then we've got 11 minutes, and this 54.93 seconds. Now because this section here is over 30, we have to round this 11 up to 12. So it'll be 68 degrees and 12 minutes. And you need to write that down. Okay, example number 3. Same idea, but sometimes you're given your right angle triangle inside larger triangles or inside a number of triangles, and also you can be given them in worded questions where you've got to draw your right angled triangle just from the information that you're given. So for this one, for the triangular roof, truss illustrated, find the pitch of the roof. Now the pitch is the angle made from the beam up to the angle of the roof. Okay, so the rafter beam is 13.8 meters. So this is our rafter. So we can put that information on there. It's 13.8, and it's actually the hypotenuse side of this right angled triangle here. The height of the roof is 4 meters, so we put that on our diagram. So any information that's given to you in the words, you've got to make sure is in your diagram as well. That side is the opposite side to the pitch angle. So now we've got our opposite and our hypotenuse. We know that that's sine. So you set up your ratio by substituting in the opposite of 4 and the hypotenuse of 13.8. To do that on your calculator, so clear that, shift sine of the fraction of 4 over 13.8, arrow across, close your brackets, equals, to put it into your degrees and minutes. So we've got 16 degrees, 50 minutes, 57.41 seconds. So if I was rounding that off to the nearest minute, it would be 16 degrees and 51 minutes. Okay, and that's how you write it. So if you can write example 3 down.